So much for coming tonight. My name is Nicholas. I work as our marketing and community lead here at Code Chrysalis. And tonight we're going to have two really cool speakers and really cool talks coming up. So first we'll have Stefano talking about JavaScript for IoT. And after that, Julian will talk about functional programming mentality. Just to talk a little bit about the householding stuff, if you need the Wi-Fi, you can log in at Code Chrysalis Guest. There should be no passwords there. Bathrooms are all the way to the back and to your right when you're actually like walking there. And we have a really cool barista tonight, so please have some coffee also during the networking time if you haven't had yet. But before we kick off the talks, I'll just kind of briefly talk to you about Code Chrysalis and who we are. For how many of you is this your first time here at CC? Okay, maybe around a third. Felix, I think you've been a few times. Thanks for streaming. We are also streaming, so if you want to share this to your friends who couldn't make it tonight, please do so. You can find us anywhere online, I think. But let me just briefly give you the brief to us, if this works. There we go. Yeah, so let me just iterate our mission as Code Chrysalis. So we have 3 of them. We want to create engineering leaders. We also talk about KEYP here. So KEYP stands for communication, autonomy, technical skills, and empathy. So we think that technical leaders should have all of these capacities. And also empowering women in STEM and technological careers, and community building. So we host a lot of free educational events where we encourage speakers, such as Stefano and Julian, to talk about their knowledge and share it. And we also encourage you to do so. So if you're interested, please reach out to me. Sorry about the HDMI cable. So I'm going to quickly run through this. We are most well known for our immersive bootcamp. This is a 12 weeks full stack, full-time program. So if you're interested in, we have some flyers in the front. Also, anyone who's wearing this shirt today will tell you more about it. We are looking for technical skills and communication skills. So there's a bit of an admission process to get into the bootcamp. But again, if you're interested in it, let me know. And I'll also be happy to talk about the curriculum of the program. These are some of the companies where our graduates have been hired. So I'm sure you can recognize many of the logos on the screen. And our part-time programs, so we have also foundations. So if you are just starting your journey to coding, or if you're interested in JavaScript, we have a 5 weeks part-time course. So this is a few evenings during the week and Saturdays, so you can also do it if you're working. Also Job Leap, this is our newest program. This is for current software engineers or recent graduates from a bootcamp or from, let's say, computer science major. So this is a job hunting prepping course. So if you're looking for a new job and kind of need to enhance your skills in, let's say, technical interviews or negotiation strategies, this might be something interesting to you. And then we also have programs for enterprises, but for those, please reach out to us and we can talk more. Another event that I already want to mention is our mini-conf, which will be coming on November 14th. But without further ado, please do follow us online everywhere. We are there, Code Chrysalis. Also today, hashtag Code Chrysalis, when you see something cool, maybe from Stefano's IoT, which we will be starting next. So that's all from me. Thank you again for coming, and also big thank you to our awesome speakers today. And I will let Stefano take the stage now. So let's welcome him with a round of applause. Is this okay? Oh, yeah. Just this one? There you go. Yeah, this one I don't have too much of it. Sorry. All right. Thanks. This mic.
All right. Good evening, everybody. Thank you very much for being here tonight. I'm really excited to tell you a little bit about the topic that I've been explored and that I prepared here for you, which is, as you can read, JavaScript for IoT. In particular, we're going to explore how, by using JavaScript, we can actually start experimenting with IoT devices. So let's jump right in. Let's talk a little bit about the agenda. So to begin with, obviously, we're going to talk about IoT. We're going to see what it is and what we can expect from it for the future. Later on, we're going to talk about Johnny5, which is a JavaScript framework that I use for these experiments. Following, we're going to talk about the hardware of choice, which is the SM2, a small SBC, or single-boarded computer. And finally, we're going to see the experiments as well that I performed. Okay, but actually, before continuing, let me just introduce myself, maybe. So, hello again. My name is Stefano, and I've been living here in Japan for 1.5 years now, and I am a graduate from Code Chrysalis 9th cohort. Whoop whoop, CC9. And yes, I am Italian, as I mentioned. Although I come from a small village from the mountains, and as such, my village actually looks much more similar to Switzerland than it does to Italy. And I don't have a technical background. I'm a linguist myself. But I like to say that I've always been involved with technology all my life, since I was a kid. That's particularly because my father is a software engineer. And as a kid, I always wanted to become like him one day. But growing up, you hit your youth and you start to want to be someone different. And hence, I started traveling around the world. So I was actually a backpacker. And I learned how to speak in different languages. As you know, I'm a linguist. So after 4 languages, and the 5th one coming, which is Japanese, maybe one day, and traveling every corner of the world, I decided that I wanted to learn how to talk with computers as well. Hence, I decided to take Code Chrysalis cohort. So yeah, now you know me a little bit better. Let's dive right in. Let's talk a little bit about Internet of Things, or IoT. And maybe we can start with this question. So, what is IoT anyway, right? So, if you look on the internet, there are many different definitions of IoT. But in general, we can all agree that it is any device that is connected to the internet and that can be controlled through another device. So, technically speaking, they are connected to the internet so that they can be better and help our lives to be better as well. We can divide IoT devices into 3 categories. The first one are devices that can analyze their surroundings, and then they can send this data, collected data, through the internet. For example, I don't know if you can see it here with this white background, but anyways, this is a thermometer. So it's a thermometer that checks your body temperature. And in particular, this thermometer, after check your body temperature, will send this data to your phone, where you can see the history of your health status. Or else, as well, you can send this data to your clinic, so that your doctor can actually know how you're doing. Then obviously we have the devices that can receive data from the internet, and then they can perform an action out of it. Take, for instance, a 3D printer. So a 3D printer like this one connected to the internet, rather than to a cable and a computer. I know this might not sound as exciting as this other one that I presented before, but think about this. A 3D printer like this one, well, a little bit better than this one, it's actually on board right now of the ISS, or International Space Station, and it's orbiting Earth around 450 kilometers above our heads. So why is it there? Well, astronauts need to perform very specific actions in space, and not always they have the tools that they need. So what they do, whenever they need a new tool, they actually ask the people at NASA on Earth to send a blueprint to this 3D printer. And in a matter of seconds, they will be able to upload it and send it to this 3D printer, and then print it and perform the actions that they need to do. And finally, obviously, we have IoT devices that can actually perform both of these actions. So, analyzing their surroundings, and send this data through the internet, and also receive data from the internet and act on purpose. For instance, in this case, as you can already see, a self-driving car. So self-driving cars have sensors around all of the vehicle that can help them navigate in their environment, and they can also send this data to a data center to the internet, so that it can be used from other self-driving cars. And also at the same time can receive data from the internet and that maybe can help it decide which is the best route to take in order to take us to the safest location, to our location, the safest way. So okay, we've seen these three categories, and how about we talk a little bit about the future for IoT? So, IoT forecasts. So according to Statista.com, as of today we have 26 billion and a half devices connected to the internet. And still according to the same website, by 2025 the number will skyrocket and will triple. And we will have about 75 billion devices connected to the internet, generating a market share of 750 billion US dollars, which if you ask me, is a lot. And obviously after seeing all of this data, I asked myself, so what it is needed then to become an IoT developer? So, as of today, if you want to code or you want to develop an IoT device, you can do everything from A to Z by using one of these three languages. So, C, Python, and Java. From A to Z. But obviously, I mean, the language that I know the most actually is JavaScript. And so I asked myself, is there anything that I could do with JavaScript maybe? I want to do the same thing that I can do with those languages. Can I? Obviously, it is a rhetorical question. You all see the topic of my talk, which is JavaScript for IoT. Hence, let me introduce you to Johnny 5. Johnny 5 is the framework of choice that I'm using this time, and it's a framework for robotics and IoT. And in particular, this is the actual definition of it, which is 25 is an open source Firmata protocol-based JavaScript framework. As open source, obviously, as all you know, you get access to the source code, then you can get access to it, you can use it, you can modify it. Firmata protocol basically means that it's actually based on the Firmata protocol, which is a protocol allowing communication between microprocessors and software on computers. And finally, it is a JavaScript framework. So obviously, it is a set of code already there that you can call inside of your program and you can use in order to perform actions in a faster way. The beauty of Johnny 5 is that it's thanks to this Firmata protocol, we can actually run it on all our Arduino models. We can run it on a lot of SBCs actually, which stands for single board computers. Not only on all Arduino models, but also we can run it on Raspberry Pis, BeagleBoard, and SparkFun Red board. Well, more of these actually. This is not a complete list. There is way more than that, and I actually suggest you to go on the website to explore and see how many other boards you can actually use it with. And why actually this? Well, Johnny 5 is here to help write programs for single board computers in a much more familiar way, especially for web developers like myself. And with this, I obviously want to show you a little bit of code taken from a Johnny 5 program, so that you can actually see what I mean with this. So here you see, this is a program written with Johnny 5, and this is actually helpful. It's going to run a very simple code to blink an LED every 500 milliseconds. Pretty simple. As you can notice, if you have familiarity with JavaScript, you can already notice some of the typical things that you can see in JavaScript. Here we declare the dependencies, so we are requiring testcell, which is the Firmata protocol, and we are requiring also Johnny 5, so the actual framework. Here we actually declare a new board, a new constant variable board, to which we assign an object coming from the Johnny 5 framework. Inside of it, obviously, we are telling it to mount the Firmata protocol for the testcell, so that it actually knows it's a testcell. Right here. And then obviously down here we have the actual method that will run the program. So the on method actually accepts two methods, two parameters, excuse me. One is ready when, so it actually tells it to run the following function whenever it's ready. And instead of this function, we are obviously assigning to a constant the new object LED, to which we are telling it which door, which port to send the energy to. And finally, the method, so blink every 500 milliseconds. Whoa. Okay, we can do this. And if you do everything correctly, at the end, the LED will blink. So let's compare it maybe with some other language. Let's compare it with C++ here. So just running real quick, here we have the setup function. In here we are telling it to that the output for this, in this case, will be the pin port at 13. And then we have the loop. Here in the loop function, as you can tell already, we have two other functions. We have digital writes and delay. Digital write, the first one will send energy to the port 13, and the second one will take the energy out. And the delay, well, the delay actually stops the program running for 500 milliseconds. So this is how you obtain the same effect that you can obtain with Johnny 5. Well, now that you can look at it from here, you can kind of tell that they are not so different. And honestly speaking, well, they are both actually understandable, right? So why actually going through all of this effort into writing in Johnny 5 when you can obtain the same with C++? Well, it is true that they are similar and they are very understandable, but what happens when you write something more complicated than this? For example, I would like you to focus on the C++ section. I'm going to change the slide, and here is another piece of code that do something different. Here we go. So, as you can tell, a lot has changed. This is the code to pulse a light rather than blink it. And does anybody notice anything different in the Johnny 5 section? Let me give you a help. There you go. That's it. That's all you have to do to to have a different action performed with the test cell than in C++ takes a lot of time to write. So just like this. Blink, pulse. That's it. Very easy. And well, let me give you a little bit of a disclaimer before I continue. If anyone here knows how to write code in C++, please don't hate me. I'm not here to diss C++. Honestly speaking, C++ or C are coding languages that are actually better at writing code for IoT. Johnny 5 here, it's actually a framework for web developers or for anyone who would like to get into IoT programming without having to tame beasts like C++, honestly, which is not very user-friendly or not very beginner-friendly, if you know me. While usually JavaScript is far more accessible. So okay, but still, yes, performance-wise, C or C++, they kill Johnny 5. So please, okay. Okay, let's move on. Let's talk a little bit about the hardware. So here we are talking about test cell 2, and in particular here you can see it. This is the test cell. I have it here right now with me. Later on we're going to show you a demo with it. It's just hidden for now. But this is the test cell. And why the test cell in general? Well, I decided to choose the test cell because it has been built specifically to use with JavaScript. So it performs better when running JavaScript. And so we can actually distinguish it a little bit. So we have a connectivity and power input over here. We have two USBs, an Ethernet door, and a USB Type 2, where you can plug your power. Over here we have about 20 input-output pins, where you can connect your modules. And finally over here we have obviously the core hardware. So we have the microprocessors over here, 500 megahertz of power, very powerful. About 64 megabytes of memory. And we have a microprocessor as well to help with compiling the code. And obviously we have the bandwidth over here for the internet. Okay, so the beauty actually of the tester is that as well, I don't have a slide for this, I'm sorry, but we have a lot of modules that we can use in order to experiment. So I will definitely suggest everyone to have a look at their website. They have the tester, they have a lot of modules that we can buy or we can get access to relatively cheap in order to perform a lot of experiments such as accelerometers, also the moisture thermometer as well, lights. So it's plenty of things to experiment with, especially for beginners. It's very, very useful. So moving on this one as well, let's talk a little bit about my experience with it. So let's assume that everyone here will actually would like to start a little bit of IoT development with me. The first thing obviously to know is that I'm running a particular setup here. I have optimized everything so to run on Ubuntu 19.10, even early, and using Node.js 12.8.1. In particular, this is my software of choice specifically, but I will suggest everyone to check for your own for the better version for Node.js that works for you, because for me as well, not all versions work, so I settled for this one. It works the best. So yeah, especially if you're running another operating system. And so obviously, if you want to start a new project, let's open a new. Let's actually create a new directory, name it whatever you want. Then you have to start the project itself. So run yarn init, or if you prefer npm init, and fill out all the information. Following, obviously, still yarn add, we have to add the dependencies, in this case, Johnny5 and Tessel.io. We're going to need them later on. And then, obviously, we have to install, if you didn't already, install the Tessel2 command line interpreter. In this case, I decided to go and install it globally, so that I don't need to reinstall it every time I run a new project. And that's basically it. So this is what you need to set up your environment and start experimenting with JavaScript and IoT. And if you did everything ready, by calling T2 list in your terminal, you'll be able to see something like this. Yep. So yeah, it's quite awesome, especially the first time you run it. As you can tell, obviously the name is not exactly the most memorable one. So T2 actually accepts many different commands. You can also run T2 name and set up another name, the name that you prefer, so that you can actually you can assign a name to your test cell that is more memorable. And so yeah, so first experiment after setting up everything, and here you go, first experiment that I performed. So this is a little circuit. This is the blueprint of the circuit that I built. Real quick, I think it's necessary to explain. Please stay with me. So this tool that you see at the bottom, behind everything, with a lot of the holes, is called breadboard, and this is incredibly useful if you want to start experimenting, because this is what you're going to use to create a lot of different circuits. And obviously, it's reusable all the time you want, and it's great for experimenting. These are all jumper wires that connect the test cell to the breadboard in order to pass the electricity. These are resistors. Resistors are useful in order to keep the flow of electricity under control, so that you don't burn down everything. And here we have LEDs, different colors. So LEDs have two legs. The longer one goes inside here. Goes on this side, so that because it receives the electricity, and it's called anode. And then we have the cathode over here that actually goes into this little channel. This is actually the discharge channel. And it's really important to set it up in this way, because the opposite way, well, it wouldn't work. And finally, obviously, to close the circuit, which is quite necessary if you want it to work, it's this it's the ground jumper wire that is connected to the ground port on the test cell. Yes, so, at the beginning, obviously, this is a picture that my wife took of me when I was experimenting with it the first time. And I had a lot of fun doing it, and I think that experimenting is the best way to learn something. And if you do everything correctly, in the end, you will have something like this, running the program, obviously. And yeah, it's quite cool. But yeah, obviously with this project, I was only able to tell the tassel to run it or not to run it. I didn't really have a lot of control over it, and this wasn't really what I wanted to do. It was nice to see, but it wasn't really effective. And me as a developer, I wanted to have more control over it. Maybe through a graphic user interface. So yes, this is why I decided to go over a little bit. I built basically another project which I'm now going to demo. So excuse me a little, I need to set that. This is the tessel. As you can tell, it's quite small. It's not really visible, but no worries, have no fear. I have here something to help. This is the graphic user interface that I built, and now we are mirroring my phone, and this will help you to see what is happening. So, you're going to see, okay. So, what happens if I press a button? Maybe green, boom, and it turns on. And I want to stress this, but basically what I did, I built a web server on top of the tessel, which is now running, and it is not connected to my computer. It's all running wirelessly on the internet. So I can toggle. I wish I had another hand. I can toggle. No. I can toggle any color you want. Just please scream me a color and I'll turn it on.
Purple. Yellow.
Purple, yellow, yes. We can do that. Purple, yellow. It's a little bit fading, but it's there. The LED is not doing correct. It's not doing well. I experimented a lot with it, and the yellow is not working correctly. So yeah, it's nice, and I can also drag buttons. If I click them again, I can turn it on and off. I can drag them and drop them on the tessel image here. And in general, if I then click on the tessel as an Easter egg, boom, there we go. Yay! A little bit of colors. It's quite nice, and we can also speed it up. Yay! There we go. A little bit of disco now, and we play the music and we dance. So, okay. I'm gonna let it on, but I'm going to turn off my phone, and we can continue a little bit, so you can all get distracted and not pay attention to what I'm saying. So, this was a very quick demo, and I built it basically in 1 day only, and this is like a proof that will tell you how easy it is to start developing IoT devices or wannabe devices in a very quick time, even if you don't have experience with it. And for this experiment, the technologies that I decided to go with for the front end, I decided to use React, and obviously the Johnny 5 framework and the tessel firmata. While for the backend, which was a little bit trickier, I decided to use Express to run the server, and the communication between the client and the backend is actually done through socket.io. Apologize, there is a name here. Socket.io is another framework that is used to make the front end and the backend communicate, and it's event-driven, so you can toggle it from both the backend and the front end. So yeah, so we are reaching the conclusion of my tech talk, and oops. Here we go. So if you have to remember anything from all of this, of what I said, I know there was a lot to process, a lot to remember, but if you have to remember something, obviously remember that with IoT, these are devices that are connected to the internet and they can be controlled through another device. And in particular, that there will be more and more devices connected to the internet. This is the future. Johnny 5 and Tessel 2, they are an easy way to get into programming IoT while using a friendly programming language such as JavaScript. And finally, obviously, well, that it's very nice to experiment, and it's the easiest way probably to learn something, and I will suggest everyone to do so. So thank you very much for your attention and for your time. These are all of my contacts. You can get my GitHub here and my email. And please connect with me as you will, as an IoT device will do with the internet. Yay! Thank you.
Thank you, Stefano. We have time for a few questions. If someone has very quick questions right off the bat, we can take a few of them. Otherwise, we can also save them for the networking. But if someone has a question, now is the chance. Yeah?
I'm interested.
Yeah, please.
Hi, I'm Amir.
Hi, Amir.
My first time here.
Welcome.
So I'm interested to know what sort of setup that you had to do on the what's that called again?
The Tessel?
Yeah, the Tessel.
So there was no...
in order to receive what I presume to be maybe HTTP requests from your machine, from your computer.
Sure. So everything is dealt with socket.io. That's the framework of that I chose. Technically speaking, socket.io is basically I start the socket.io inside of the server, and once I start it, basically we listen to anything that is happening. I assume every second is listening to what is happening. And whenever I toggle inside of my front end, obviously I call socket.io in my front end as well, and I let it communicate with the backend. So anytime I perform a click on my graphic user interface, I send a signal to socket.io that then is transmitted to the backend. And at this point, obviously the tester will take care of the rest.
Okay, good. Thank you for the question. Maybe one more if we have here. Okay, that's good.
Just to follow up on that question, so
Yes.
is there any authentication mechanism between Tessel and your backend web server?
Once again, sorry?
Is there any authentication mechanism
Yes.
that could be set up between Tessel and your backend server, the
Yes.
HTTP server?
Yes, definitely. There is another of the T2 commands that you can run in the command line. There is called T2 provision that will authenticate your Tessel and will create an SSH key that will keep obviously the communication safe.
Thank you.
All right.
Cool. Thank you for the questions. If you have any more, please grab him during the networking session. But let's give one more round of applause to Stefano. Thank you. And next, I would like to invite Julian to give the second speech of tonight, which is going to be about functional programming mentality. So let's give a big round of applause to him as well. Yes.
Make sure.
It's not showing secrets.
Yeah, that's the main point. Okay, should be fine. Or yeah.
Not show this?
Oh. Oh, what? Does it handle splitting?
You can also see.
Okay, okay. It's just typical splitting. It's split it, so. Remove this. Okay. And hopefully. Seems good. Okay.
So, hello everybody. This is my first talk here at Code Chrysalis. I hope it's not gonna. I hope there's gonna be more. So excuse my little disabilities for talking today. First, I'm gonna introduce myself. My name is Julian Hora. I've been an engineer for 7-8 years right now. I'm especially working with JavaScript and Swift because those are my favorite languages. I'm a full stack engineer, so I can cover backend and front end, and I guess that's why also I was interested into exploring more paradigm than just object-oriented programming, because lots of things can't be done with this, especially if there is some data oriented people here. You know what I'm talking about. So first, let me tell you about what this talk is going to be about. This is not going to be about why object-oriented programming is bad or why functional programming is the best. It is the best, but that's not going to be the main point of the talk. It is more going to be about what kind of mindset surrounds functional programming, what kind of way of thinking of or refactoring your code can also affect your daily life or the way you see things around. So let me make sure of this. So let me take some in real life example. Let's pretend that you want to move you get an instruction that you need to move an item from point A to a point B, and this item is inside a box. You don't know why, but there's a box. Every time you see this item, every time you have to repeat the operation, there's a box. The instruction doesn't mention the box, but the box is there. The point is, the object-oriented people will take the box with it, with the item, and just move it to a point B. Functional programming is about reducing those kind of extra wrapping that are useless, basically, for achieving your action. The name says it, it's functional. So we would just take the item and put it in point B. Now another reason why it changed my way of seeing code is I started seeing useless pieces of code. For example, typical example that anyone in school or in very low operation will see is you have a user, you have data about users, you always have a class users and then some children user. And you don't really know why you're doing it. This is just the typical process you're going to follow. But do you need it? Do you need that class? You don't really need it, actually. You will see that working with functional programming and few parameters, you will use way less computing power to achieve the same thing. For example, in real life, this could transcribe to when you're talking with your neighbor about your cat, do you need to say that your cat is of feline type, I think we say in English, and then again, from the higher class of mammals, you don't really need to say it. You can just talk about your cat because you know what is a cat, and you can go straight to the point. Well, this is functional programming. We don't have all those extra classes around, all those extra wrapping. And this is pretty much why it can really change your way of seeing things. Let's say you're seeing a problem, you're facing a problem, and you have to think about a solution for this problem. Think about the time you need if you start considering all the context, all the coding there is around the main problem, the core of the issue. If you directly switch to the core of the issue and you find out that you didn't need the context for this issue, then in the end you just earned time. You just went straight to the point. That also impacts, for example, your talking skills. You can put a lot of coding around everything, but when you're doing, for example, higher level business, you can then learn how to manipulate your talk, to orient your talk, to use less coding, to go straight to the point. And that's basically, thanks to functional programming, I really started entering this mindset, and it really, really helped me in my daily life. So some of the key points of functional programming, the first one I would say is that it's really, really easy to read. Let's take the example of you're receiving some task that you have to work on some code that someone else wrote. And that code is actually, how can I say? That code is full of classes. It's full of instantiations, full of dependencies in other files. And it's commented, but still messy, because it depends on so much context around the code, the function variables, and everything. Now, it will take you a certain time to understand what is related to what depends on what needs to be there before this other guy, and so on. But if you're in functional programming, especially if we're talking pure functions, then you don't depend on others. You don't depend on other parameters that weren't calculated before. And that's one of the main key points, I would say, of functional programming, is the way that we say, let's remove attachment between different components because we're going to get in trouble. And you can see it. I'm going to quote an example of real development a bit later today, and you will really see it applies in development situation. Another huge key point is lazy evaluation. And this is really where it applies to real code. Let's say that, is there any iOS developer here? No? Okay. Crazy, insane. So you should. For example, if you're working on iOS, classes will be computed at runtime. So when you run your app, it will basically try to compute and calculate everything in your class. It will say, do I have this settled or not? And if something is not settled at runtime and it's in your class because it's going to be computed, then, it's going to crash the app most of the time. So let's say that my function doesn't need to be in my class, I don't really need it. And then it turns out if I just put my function in a pure Swift file, or it could be JavaScript, but anyway, if I just leave it alone and don't try to scope it or contextualize it, well, no one is going to ask it to run. So now it turns out that I could have a function that was requiring a parameter that wasn't calculated yet, but it's not going to be computed before I call it. And this is where it really changes from object-oriented programming, because every object is going to be trying to be compiled before in those mobile environments, for example, Java, for Android. And this is also where there is some constraint. You can't do functional programming everywhere. If your environment is already set up in a way that everything depends on objects and instantiations of class, then you will not be able to do a full functional programming setup. For example, if there is any person who touched Flutter here, or this is very simple, well, you know, everything is stored in classes named widget, and you can't do anything without widget, or states attached to those widgets. If you are trying to do functional programming in there, you will always get errors because it will ask you for instantiation all the time before. The only way you could accomplish using functional programming in Flutter is rewriting the Flutter SDK, which I'm trying to attempt now, and actually it's really difficult, which I'm trying to attempt, but the results are that now I'm rendering everything through a single function, so I'm going the functional programming way to render, and rendering through one single function takes half the time than Flutter takes normally. Okay, another part which is very close to what I just spoke is nested functions. Means that they're going to depend only on their parent function and never of a context. So you can still have structure and let's say variant calls, but you don't need to depend on a class, for example, to hierarchize your functions.
Mm-hmm.
And finally, for the key points, if anyone have worked with parallel computing, such CUDA technology, all those kind of things. For machine learning, it's very useful, basically. You only have functional programming as a solution. This is the only path to achieve it, because you need to be able to create functionality within every part of your code and timing. To come back to what I was just saying, when you read about functional programming, lots of people will say, forget everything you know about programming, but this is actually so wrong. It's just about rethinking what you're doing. Why do you use this? Why do you follow this process? I think the main point of learning functional programming is not only functional programming itself and the way you're going to refactor your code. It's also about changing your mindset to actually question yourself about why you're doing this or that. Again, the same example I used earlier about you have the typical class of users with child user. Most of the people will do it, but they don't really know why they are following this process. It just makes sense for them, that's the only way they know. But actually when they're going to investigate, they will think, well, I have extra structure that actually make my code heavier for no reason and requires me more effort, more hierarchy that shouldn't be there. But again, it's going to be difficult to switch, to shift to this paradigm, but it's not impossible, and it's actually very beneficial for the clarity of your code. The clarity for the next person who's going to come after you, the clarity for yourself when you're going to reread your code, when you're going to debug. I mean, debugging functional programmed code is totally different. You don't have to see, okay, this class is wrong, something's wrong with this class, but then I have to investigate what's wrong within this class. It will never happen because all functions are independent from each other. Because there's no dependency, and this is all about functionality, you don't have to go through layers in debugging. So it will be difficult, again, to shift. And it will be also depending on the environment, like I talk about Flutter, for example, or Java. But it's not impossible, and I would say that the shift starts by really understanding how you can just try removing things out of your class. Like you have a class, you have lots of things inside, just put them out of scope and see what happens. And I think you will really be hit by how much, oh my gosh, like, why is it still working? Why do I still have access to this? I thought this is restricted. And you know, all those kind of cliche we have about programming will slowly start evolving about that. Oh, okay, seems like I can do this, seems I can be faster on this part. And as you can see, this is evolution of programming. Okay, so my final point, I would say, about this mentality is, again, it can really change your mindset for everything. It's going to start from code, and then your daily life will be impacted with different way of seeing things around you. Solve problems, approach challenges will be totally different. It's everywhere. Object-oriented is everywhere right now. And it's like something that doesn't want to detach from the actual word, but should be put off, basically, as much as we can. And when you're going to be trying to shift to this paradigm, the first thing you're going to think is, oh my gosh, it's going to take so much time. There's this package, but it's object-oriented. I'm using this module, but it's object-oriented. And it's going to take time for you to rewrite all of these in functional programming, but it's really worth the time investment. Because if we don't try to change now the way things are done in code, and if we leave the task for others, we're just going to keep delaying the progression of development. And I really strongly believe that we all need to be part of this evolution. So that's it.
Thank you. some questions from the audience as well. So who wants to go first? Anyone? Go.
What functional program language do you like to use most, and what one do you recommend for beginners to get into?
So, as I said, my main languages that I'm using right now are JavaScript and Swift. They are not made to be functional, but I would say that they are at least built in a way that you can make your own choice about how you build things with it. In Swift, for example, you can depend on already existing class, which you will need anyway, but you can wrap everything in functional programming standards. And JavaScript, I would say, is the easiest to experiment with functional programming.
Thank you. I think I had another hand over here.
Much of the features of object-oriented programming were results of thinking about the structured analysis from very decades ago. How does that kind of thinking transfer to functional programming? Basically, how do you break down a very large enterprise app and read the functional programming?
So what is the question exactly? Which part do you want me to break?
What are the tools that functional programming give you to be able to analyze a large problem and write code for it?
Okay.
The reason we have objects is to basically simplify complexity.
Well, it doesn't simplify complexity. It adds complexity layer to things that doesn't need it. But yeah. So you're asking me an example of how it could benefit, for example, an enterprise app. Okay. Okay. Let me think. Okay. If you have experience working with tools like Firebase, for example, okay, you need initialization functions in your app to run at when your app starts and your app delegates. You basically need them. It's initialization to give you access to your own database. If you go in an object-oriented way, Firestore itself is going to be an object. I'm saying because I think you already know what is Firestore. Okay, Firestore is going to be an object, and it will try to compute before everything else has finished computing. And it turns out that, for example, your API key will not have finished processed. The informations are not answered before. We need functional programming approach to basically take this out of scope, take this out of context, and only call this initialization in a timed chain at the end of our app delegate, basically. We have to time this, and this is only possible by going the functional programming approach. So this is one of the most typical case of iOS development, is when you start to need to develop with Firebase, you will need to see functional programming.
So we just say that it's better suited for event-based programming.
For what, sorry?
Event-based.
Yes.
Maybe time for one more question. Anyone's got a burning one? No? Do we have to leave it for the networking? That's also okay. Okay, well, without further ado, I would like to give a big round of applause to both Julian and Stefano for coming tonight. Thank you also, all of you, for coming. We have some time for networking. Also, I think Shinji still has some delicious coffee and tea back there. So if you haven't had some yet, please take some. Crack Roaster has been kind enough to sponsor us tonight. And yeah, another one coming up November 14th is our next mini-conf actually. It's going to be here. We're going to have 4 speakers, so please do join if you find this interesting. And if you have any questions that you didn't have the time to raise right now, please grab the speakers and do stay for a while and get to know someone you haven't met yet. But thank you all for coming from my behalf as well. Cheers.